Hello everyone, this video is going to go through basic fire dynamics simulator model building and running of the model. We're going to break the video into two parts. The first part we're going to run example files that are provided with the installation and talk about a few things dealing with the program, and then the second part we will build out a single room and see how we can change some of the things in the model. So to start with, we need to get the model files, and so if you install the program, if you use your favorite search engine to search Fire Dynamics Simulator NIST, there will be a free download available. And it should install somewhere like C:\program files FDS. This video is going to use FDS version 6.1.0. And to find example files, there's a folder called examples that installs with the program. And one of the ones we're going to look at is in the fires folder inside of that location. Now, I wanted to show specifically on this computer, I haven't installed FDS. What I've done is copied the files from this FDS 6 location into a flash drive. And so this is drive D. If I look at this PC, I have this USB disk D. And if I go in here, I have my FDS 6 folder, and inside of here I have all the files that were installed when the program was installed on my other computer. And the reason I do this is a lot of times when I'm teaching people how to use FDS, if they don't have their own computer, they may not have administrative rights to a computer they can access. So if they can get access to a library computer or a computer lab computer, if you have these files on a flash drive, then you can run the program either from the flash drive or copy these folders onto the desktop of that computer and run the program from there. I'm going to copy the folder. I'm going to copy the files from the USB onto the desktop because there can be some delay if you're running the program from a USB port. As technology improves, I assume that delay is going to get smaller and smaller and smaller, but currently there is, when I tried the two ways to do it, and the USB was definitely slower with the setup that I have, but I don't want to spend time going through that. So what we want to do, we're going to make a file on the desktop. We're going to call it Room Fire version 01. I like to name files and folders with versions so that I can keep track of what I'm working with. That's especially important when you're changing small things in a model. Maybe you're doing a mesh analysis, or you're changing some small amount of the geometry. So I'm going to copy all of the files from the bin folder, and I'm going to put them in here. And so it's only 15 megabytes worth. And in here is your FDS application. Your smoke view application is here, and the rest of these do different things. So rather than try to figure out the minimum number of files I need to copy, I just copy the whole bin folder. And then we can go in. There's a lot of different examples that they provide with the installation, so very helpful with learning how to do certain things. So I have a section down below in the second page. Interesting examples to run. There's an evacuation example, wildlife urban interface, spray fire, sprinkler and sprays, atmospheric effects, a stack effect. There's also a fire whirl simulation that has multiple meshes, so if you're interested in figuring out how to do a multi-mesh simulation. that is one place where you can find a script, an input file that already has done that. So we are going to go to the fires example and find the roomfire.fds. And we're going to copy it into here. Now these on this computer, because I was trying this out before I made this video, this .fds file type is already associated with Notepad. So if I double click it, Notepad opens it. But when you open it the first time, you need to tell the computer to use Notepad to open it, or some other text editing software that doesn't add the extra information that the FDS file won't know how to read. So basically, this version of FDS on this computer in this setup, it'll run a .fds file or it'll run a .text file. And when we modify this example, which we're going to do in the second video, it'll change from a .fds file to a .txt file, just because Notepad's going to save it as a new file. And there's a way to prevent that, but it hasn't been a problem, so I just let it change to txt and go on. I do have a couple of notes here on FDS is run from the command prompt, so we can get to this a couple of different ways. We can click on the Windows button, assuming you're running a later version of Windows, and search for CMD, or you can hold the Windows button down and click R and type CMD into the open line, and we will get a command prompt. So we've made a folder on the desktop, and now we want to get to that folder. So we're going to change directory, type D, and if we hit tab, it'll fill it in, assuming a directory that starts with D is available. And so hit enter, and now we're in a directory. If I type dir, I can see what's in my desktop directory. And so if I look here, this is my roomfire version 01 folder I just made. This is the simulation I ran earlier because I wanted to be able to show what the simulation looks like after it runs. And it takes a little while for the simulation to go. A couple other handy commands. CD is change directory. If you do CD with 2 spaces or 2 periods, it will move the directory back 1, and then Control C will stop a program. So if I wanted to run FDS, so I'm going to change the directory to my roomfire, and I want the version 01, so that was a double tab. And then if I put in my directory, I see I have my FDS application and my roomfire.fds here. So I'm going to type FDS space roomfire.fds, and I'm going to hit enter. Now there's a bunch of, you can make these commands more specific to where this program will run in the background. You can control how it accesses your computer's memory and processor, because some of the reasons are you might want this to run in the background is if I close this window right now, the program will stop. And maybe you don't want to have a bunch of windows open if you're running a bunch of different simulations. Yeah, so I'm not going to get into that here, but it is an option. So the simulation started. This is the simulation time. So in the simulation, I have 2 seconds worth of modeling done. If I wanted to stop this simulation, I can hit Control C, and it will stop it. And if I go to my roomfire version 01 folder that I created on the desktop, I can see now there's a bunch of new information here. These are all output files from the model. And if I double click on the smoke view application and I go back to my desktop, I can open my roomfire version 01, and this is the model that we just created, the roomfire .smv. And so we have this model with one room and some furniture. These walls are made so that you can see through them when you look. And I can load, let's say I might want to load the smoke, but since I only have 2 seconds worth of simulation done, there's not much I can see. So we're going to close this one out. So to run smoke view, I can either double click on smoke view like I just did, or you can right click on the .smv file and tell smoke view to open that file. So if we go to this one I ran before, I could have used the other smoke view as well. I didn't actually need to open this other folder. So same room, but now this one I let run for a while. It's still not completely done. The simulation is set up to run for 100 seconds. So if we go to this the input file, this one, if we look at this, we have our time end is 300. So I let this run out to 70 seconds before I stopped it so I can make the video before the day's over. A couple things I want to point out here. This is in this header line, the end headline, you have your room file and then a title. And so this room file is going to be the name of all the folders and output files that FDS generates. So if you change the file name but don't change the header line name, the files from let's say I had a room file version 1 and a room file version 2, and in the version 2 I didn't change this information. When I run version 2, it's going to overwrite the files from version 1. And maybe I want that to happen, maybe I don't. This mesh line is going to determine how many grids are in our model. So we have a 5.2 meter X direction and 52 grids, so it's a 10 centimeter grid spacing. And you have should have 5.4 in the Y and 2.4 in the Z. So we have rectangular 10 centimeter cubes, not rectangular, 10 centimeter cubes. So check your user's manual. You don't want to have non-cubic grids too much. You can vary the spacing in the different dimensions some, but there's a limit. So we can do a few different things here. We can show this particular model, and I'm not sure it hasn't been changed since it was installed on my other computer. I don't remember, because I thought the fire got a bit bigger. But the fire seems to have tapered out here. It starts and then nothing else ignites. None of these other materials ignite, and I thought they were meant to. But I don't remember, so maybe not. So we can tell it to load the heat release rate per unit area, but since this fire is so small, it doesn't really show much. We can see the smoke coming out of the door, and then it's exiting. It's actually this roof is sealed, so it's actually going to exit out the front pane rather than just straight up through the ceiling. Unless that's been set to open. It does look like it's going out there, but I think I'd have to double check that, because I think down here, when we modify for the second one, we're going to add these lines Z max equal to open, so that our the smoke can vent out of the top of the simulation space. Okay, so we have a few different things we can look at. We can load the smoke, we can load slice files of temperature, which are quite interesting. In this simulation, there's only heat release rate, temperature in two different locations. One going out the door and one at the fire location, the initial fire location. We have some boundary file information. We can display the wall temperature. So you can see it's loading in the window behind the actual display. Maybe we want to unload all this stuff. Maybe we want to load that boundary file. Just out of curiosity, I don't remember what particles are in here. Oh, I wanted to load that boundary file. So it's still loading here. And then maybe this is playing too fast and I don't like it. So I don't like the speed, so I can go to options, go to max frame rate, and if I wanted it to play in real time, or I want to see it a little faster but not quite as fast, I could change it to something else. I can also render. If I want to render, I can make a picture file be created. So if I can do all of the frames, I can do a single frame. If you want to do a video, you can have all frames be made and then tie them together into a video. But I might want just a single frame, so if I click on that and I go to my folder where I ran the program, I should have a PNG file. Oh, no, I didn't. We're looking at the one I already ran. So if we look here, this is the room fire. Here's our PNG file, just a standard image. That is fine. So there's our image from the screen. So we can look at temperature slices, heat release rate, smoke in this example. The Excel sheet output, which is where, that's our example folder. So we have a device Excel sheet output, which is where we would get any quantitative data. Okay, I don't have Office activated on this computer. So the different devices that are in here, we have information, and so there's a set of thermocouple trees inside of our, if we look at our model, we have all our obstructions, we have our igniter information here. And then down here, these are our thermocouples. These are our slice files. These are our boundary files. And these are thermocouples. And if we looked back at our smoke view, we can see little green dots. So we have these thermocouple trees. If I hit Control and scroll up, I can zoom in a little bit. So we can see our thermocouple trees. We have one in the corner, one in the middle of the room, and then one in front of the door. And a lot of times in fire tests, we will put thermocouple trees like this and have a thermocouple spaced every foot from just below the ceiling to the floor. So I used to assign a project where we had thermocouple tree data and a room fire and have people try to model it using the nuclear regulatory's FDTs, the fire dynamic tools, CFAST, and FDS, and compare what the students could sort of get out of the different ways of modeling, the different sort of levels of modeling, from a spreadsheet to a zone model to a field model, and write a report on the ease of use versus the data that you get out of it versus how well the model that was run actually matched the real experiment and the temperatures that were seen in the actual fire. So look in your user's guide to look at exactly what information is contained in your underscore heat release, the underscore HRR Excel file. I don't remember all of the ins and outs of these different columns, and it changes potentially as a function of version. So like I said, this is version 6.1.0. I think I originally started working with FDS version 3 or 4. So every time a new version comes out, we got to go revisit the user's manual. So rather than tell you specifically what this version does, I'm going to give you sort of a general overview and recommend that you check your user's guide for the current version that is out, because I believe there is at least one newer version, potentially two, since the version that we're looking at right here. So the obstructions, just a quick note about the obstructions. We identify those in three-dimensional space using Cartesian coordinates, so xmin, xmax, ymin, ymax, zmin, and zmax. So when we look at these obstructions, which are conveniently identified as the couch seat cushion, FDS is going to read this line. It's going to read from the ampersand to this forward slash, and anything after the forward slash it's not gonna look at. So that's where you can write your notes, and I recommend you add notes such as this. You got an ignition source in the couch, though this doesn't have an ampersand, so I don't believe it's being read right now, which I may have modified, or someone may have modified this example file before it was copied off of the other computer. I haven't checked the original installation files to see if this ampersand is missing, because there's one more, like this obstruction is missing an ampersand. So it shouldn't be read. It should only read things after the ampersand, between an ampersand and a forward slash. That's my understanding. So this obstruction, like the seat cushion here, these are its coordinates in the x direction, these are its coordinates in the y direction, and these coordinates are in the z direction. So I like to draw, if I'm coding something by hand, I will try to draw it out and identify the three-dimensional coordinates. Okay, so that is a general introduction, running examples from the original installation, being able to run the installation from a flash drive or from the desktop, but also on the flash drive. This video hasn't been running too long. I suppose I could run one on the flash drive itself. So if I go to the flash drive, and let's say I create a new folder. I'm still going to want to copy the bin folder in. Because since it's not installed, if it was installed on the computer, you wouldn't have to have the fds.exe application in the directory that you're working in. But since it's not installed, there aren't any root paths. Not sure that's the right technical term, but as far as I understand it, the computer doesn't know to go and find FDS as an application and run it if it wasn't installed like in a normal fashion. So if we go back to one of these windows, I can change my directory to the D drive. And if I look here, I can see here's my file I just made. Inside is all of my the stuff I just copied in. So it runs reasonably well. But I believe it's running slower than the last one. And this is a fairly simple model for what we're trying to do. But I just wanted to show that you could do it. If you want to run it straight from a USB, you can, at least on this computer I'm running here. Okay, so in the next video we are going to modify our example and run our own model. I do want to mention, I meant to mention this at the beginning, there is a disclaimer for this video. The information presented is for educational purposes only and is believed to be accurate and reliable. No warranty expressed or implied is offered as to the accuracy of the information. Neither the author nor the publisher assume any responsibility for use of the information contained herein. This information will not be used solely for life, property, safety, or protection purposes. The user is obliged to obtain professional guidance for any decisions affecting safety of people or property. So I reference the Ignition Handbook as this sort of the template for this disclaimer. It's not exactly what was used in that book, but I harp on students need to reference when they use information from another source. I haven't ever seen anybody else reference a disclaimer language, but I think it's a good idea to bring it up. So I'll also have this copied in the description of the video. So I hope you found this useful and have a good day.